Okay, so these soft story buildings, they're held up by these columns. These are the support systems, and usually there's a little footing in the ground. These attached to a beam, which is either steel or wood frame, but they're tall and they're thin and they don't have a lot of seismic reinforcement. These are the type of buildings in Northridge in 1994 when we had the large, I believe it was a 6.8 earthquake or so. The epicenter was in Northridge, and there was a lot of apartment buildings and a lot of soft stories in Northridge. And if you see on the news or you look at the photos, these particular types of constructions are the ones that had either imminent failure or severe distress in that earthquake. So imagine if that ground started shaking violently and we had a 6.8 earthquake in a close proximity. These are going to perform a lot more substandardly than a new retrofitting system or new construction that's, you know, fully seismic compliant. So these tall poles, you know, you almost consider them toothpicks. Once that ground starts shaking, what happens is the footing inside of those could either slide or shift because they're not connected to each other with a grade beam, or this pole and its connections to the flooring system are deficient. So you could have one or two things that could kick out from the ground and a sliding effect will occur, or you might have a ruptured connection from this column to that beam, which typically just sits here with some sort of metal saddle, which isn't very, you know, it's not bolted very well. There's no continuity between this column and that column per se. So it's kind of an isolated column. If this column had any failure or started to lean, it's holding up this whole wall line. This beam is supporting this whole wall above. So if that column went down, the building could be prone to collapse.